Today's lesson, section 4.5a, we're talking about exponential and logarithmic equations. Specifically today, we'll just be talking about solving exponential equations. So here I've written down some guidelines to help us understand how to go about solving for exponential equations. So step one usually wants you to isolate the exponential expression on one side of the equation. Okay. Step 2, take a log of each side, then use the laws of logarithms to bring down the exponent. So you're using your power property there. That's what they're talking about. And then the last one is to solve for the variable. Okay? So pretty easy steps. So here, for example 1, letter A, to solve this, like it says, I want to isolate the exponential part, so it's base e, and so I need to get the e by itself basically, so I need to move the 4 over. So since 4 is multiplying to e to the 2x, I divide both sides by 4, so that gives me e to the 2x equals 8. And then from there, like it says, it wants me to take a log of both sides. Now the log can be to any base that you want. And so sometimes it's good to pick a good base that helps you simplify it quickly. So a trick here is that if you take, notice that it's a base e right now. So if you take it to the base of e, so ln to both sides, so ln of e to the 2x equals ln of 8, then that means that ln of e is actually whatever the exponent is. Okay? So it kind of cancels it out and leaves you with the exponent. So here, doing that, you get 2x equals ln of 8. And so now you can solve by dividing both sides by 2. Okay? So the 2's go away, x will equal ln of 8. So if I plug that into my calculator, I get 1.04 if I round to the hundreds. Okay? Letter B says e to the 3 minus 2x power equals 3. Now e is already by itself, so I don't have to solve for anything or move anything away from it, because 3 minus 2x is all in the exponent. So here I can do my ln to both sides again. And so then now those ln's go away, so you're left with 3 minus 2x equals ln of 3. And so now I just want to solve for x. So subtract both sides by negative 3. And then divide everything by negative 2. So x should equal 0.95. Okay? Next example, letter C, we have e to the 2x minus e to the x minus 6 equals 0. So here, this one's a little different. This one looks more like a trinomial. So if you think about this as x squared minus x minus 6, think about that factoring, and you would be able to factor the same thing. So we're saying that e to the x is the same thing as x, okay, in these two examples. So that's what we're switching, okay? So for x squared minus x minus 6, you would do x, and negative would mean plus minus, and then factors of 6 that subtract to get you negative 1 would be negative 3 and a positive 2, right? So same thing, if you're doing the factoring over here, I would split up e to the 2x as e to the x and e to the x, and then negative would mean plus minus, so then factors of 6 that would give you a negative 1, or subtract to give you a negative 1, would be a positive 2 and a negative 3. So the same thing. So now you have two equations to solve for. So you have e to the x plus 2 equals 0, and e to the x minus 3 equals 0. Okay? So then I want to solve, so I subtract 2 to both sides for this one. I add 3 to both sides for this one. Okay, and then I want to do the same thing I've been doing with the other problems. I want to take the ln of both sides. Okay, so then here, ln of e just leaves you with x. So ln of -2. And then same thing here, ln of e goes away, leaves you with x, so you get ln of 3. Now, one thing you will find is if you try to do the ln of -2, you will notice that you cannot do that. Okay? Because if you go back to this first part, okay, you have e to the x equals -2, there will be no value you can plug in for x that will ever give you a negative number. It'll just give you a very, very small number because e to the x only approaches 0, it doesn't go below. You would need like an actual like -3 on the left side to make that happen. So your calculator will say error, so that means it's a no solution. So then we go to the other one, x equals ln of 3, so x will equal 1.10, and that's an okay answer. Okay? Then we have letter D is our final example. You have 3x times e to the x plus x squared times e to the x equals 0. So here we want a little bit of factoring as well, but more so greatest common factor since there's only two terms. So I see that there's an x and an e to the x in both of these. So I can pull that out. X times e to the x equals, so times, that leaves me with 3. And then that also leaves me with x. Okay, so then I can split those up. Okay, now also, these two are multiplied to each other, so I can separate those out and say x is equal to 0, e to the x is equal to 0, and 3 plus x is equal to 0. Okay, now here, two of them are easy to solve. X is equal to 0 is already done. I can subtract 3 to both sides to give myself a -3. Okay, so there's two solutions. Now here, I want to be able to solve for the x and e to the x. So if I did my ln of e to the x equals ln of 0, so then the ln of e would cancel out, leaves you with x ln of 0. Now here, if you think about this, okay, ln of 0, if you also try to plug in the ln of 0 in for x, that does not, it's not possible, okay? So this is also a not solution, because if you think about back here to this answer, okay, remember that because we couldn't plug in any number for the previous one to get -2, I can't plug in any number for x to get me 0 for an e, because it never touches that horizontal asymptote. It just becomes really, really close, but it never really touches it. Okay, so that means that's no solution. So my only solutions are x equals 0 and x equals -3. Okay, have fun.